Hello everyone, this video has been brought to you by Unacademy. My name is Mohit Gupta and in this video I will be talking about Bresenham's line drawing algorithm. So let us begin. Drawing a line on a computer can be tricky, not for us but for the computer. Why? Because a computer has to select the pixels that are the basic units of a computer screen. To draw the line to, it has to select 2 points and then draw a line between them. Also, it has to compute a lot of parameters before drawing this line, so a lot of computations are required. So, let us see what a group of pixels look like. It can be assumed to look like a matrix, as the one shown here, having axes. Let us assume that you are familiar with this Cartesian diagram with having x axis, y axis and origin. The same thing is happening here. We have the axis here and we want to draw a line from here to say this point. So now the computer has to decide at each x point these intersections, each intersection is a pixel and it cannot draw a line without a pixel. So at each x point it has to decide whether to select this pixel or this pixel. Then again the same procedure for every new x coordinate. So that is the problem that the computer faces. For example, we see here that our line starts at a pixel here and ends at a pixel here. But we have to decide at every new x coordinate which y coordinate to choose. Whether choose this one or this one, this one or this one, this one or this one, this one or this one. There are various algorithms to decide upon which y coordinate we should choose. One of them is the Bresenham's algorithm. So, how do we decide which pixel to choose? We need a decision parameter, a reliable parameter that makes the decision for us automatically for the computer to select this pixel at this position. So to explain what a decision parameter is, let us carefully examine this line at this x coordinate, say x0, and this point right here, I'll call it as y, and this will be something yk plus 1 and this will be yk. So let us assume that this is 1 unit in x and this is 1 unit in y direction. So now we need to have some parameter to decide. As you can see that this point has point of concern has two distances, d upper and d lower, from the upper and the lower y-axis pixel respectively. So we need to decide between these two pixels, this yk and yk plus 1. So I will redraw that part here quickly. This distance and this distance, this is yk plus 1, this is yk, and this point of concern is y, and this is say xk plus 1. So now we have this point. Let us assume that the equation of this line is of the form y equals to mx plus c, where c is the y-intercept, m is the slope, and x and y are the coordinates of the line. So we know that the slope m is equals to delta y upon delta x. So, and this is d lower, d upper, sorry, d upper, and this is d lower. So we see that d lower is equals to y minus y of k, and d upper is equals to yk plus 1 minus y. That is quite simple to understand. Now if we replace this value of y into these equations, d lower and d upper, then we get from this d lower is equals to m times xk plus 1 plus c minus yk, and for this point, for this equation, we have d upper equals to yk plus 1 minus m times xk plus 1 minus c. Now we will subtract d lower minus d upper. When we subtract d lower minus d upper, we get 2 times m xk plus 1 minus 2 times yk plus 2 times c minus 1, and we know that m is the slope, that is change in y upon change in x. So when we replace this m into the equation, we get delta x times d lower minus d upper equals delta x times 2 delta y by delta x xk plus 1 minus 2 times yk plus 2c minus 1. So simplifying the right hand side, we get this equals to 2 times delta y dot xk minus 2 times delta x dot yk plus this constant. Let us call this new constant as b. So what is b? B is this complete thing. This complete thing is b now. So, and let us call this complete thing as our parameter, decision parameter pk. So we have now p of k is equals to delta x times d lower minus d upper. So since delta x will be always positive, x2 minus x1 will be greater than 0 for the coordinates that we plot the line. For slope m less than 1, m less than 1, so we will have this for slopes m less than 1. Now we know that the sign of pk, sign of this decision parameter pk, will depend on d lower minus d upper. So if pk is less than 0, then we choose the lower pixel. If pk is greater than 0, then we choose the upper pixel. And this is what the Bresenham's line algorithm is. So let me explain again by a simple coordinate axis diagram. This is the axis. This is the line that we want. This is xk. This is the point of concern y. This is yk plus 1, and this is yk, and this is xk plus 1. So when pk is negative, then we choose this point. If pk is positive, we choose this point. So since pk is d lower minus d upper times delta x, so pk determines basically which point, whether yk plus 1 or yk is closer to the actual line, and it chooses that. So that is the basic form of Bresenham's algorithm, and in the next video we will talk about a formal implementation and formal procedure that is followed. This video was for understanding what a Bresenham's algorithm is. In the next video we will solve one example and have a formal look at it. So thank you for watching. Subscribe to this channel www.youtube.com/unacademy to watch the more videos in this series that are the part 2 of this algorithm and the example. Also, if you have any doubts and queries, you can tweet me to at @hi_Mohit Gupta, or you can directly tweet to the Unacademy, or you can leave a comment in the comment section of this video. Thank you for watching.